Well, good morning there, Algebra. It's good to see you. Today we're going to talk about rational exponents. It's Chapter 7, Lesson 3. Well, just like we've been practicing, exponents, you know, like x squared, that just means x times x. Well, what would x to the half mean? That would throw you a little bit, and that's what this lesson's about, okay? So I think rather than prove them, I'm just going to kind of teach you the rules, and we'll just go from there. X to the half, it says in the book, is the same thing as the square root of x, okay? And if you want to, you can prove that to yourself. X to the half, and you multiply that times x to the half, and what do you get? Remember that you add exponents, so you get x to the first. So something times something gives you x, so that means the square root of x times the square root of x gives you x, so they're the same thing. All right? So x to the half, I bet you can guess what x to the third would be. X to the third, even though we haven't done this yet, that turns out to be what's called the cube root of x. Okay? X to the 1/4 power would be the fourth root of x, and so on and so on. Now there is a little more challenging notation, and that would be like x to the 2/3 power. And at first glance, that seems very odd, but just think about it. The denominator, remember we were just doing x to the 1/3 power? So the denominator is going to tell us what square root it's going to be. It's going to be a cube root, in fact. And then x in the numerator is just going to be what power that it's squared to. So if I rewrite this, that's going to be the power of the x's to, x squared. And then the cube root is going to go here. Looks a little messy, I guess, with my or with my writing, but it's going to be the cube root of x squared. Let me have you practice one just a second. What would x to the 3/5 power be? Okay? I'll stop, look out the window, pretend not to look at you, and you do it right now. Go. Okay, what'd you get? Hopefully you got x to the 3rd power, and it's the 5th root of that. In this case, the radical sign is almost going to act like a parenthesis. You're going to do this part first, and then you'll take the 5th root of it. By the way, on your calculator, it does have a way to do all these crazy big roots. Okay, you're not going to be able to do them in your head. Every calculator is different, so I'm not going to be able to explain that to you, but you need to figure that part out. Okay? Look it up. Why don't we just practice one of those? What's the 5th root of 32? Okay? Do that on your calculator. Or, if you don't know how to do it, stop, learn how to do it, and then do it on your calculator. I'm waiting. Okay, here we are back. 5th root of 32 is simply, if you do it right on your calculator, you'll get 2. Okay? 2 times 2 times 2 times 2 times 2 gives you 32. All right. One last little section, or one last little thing. And I gotta say, this part is probably the most confusing of all. It doesn't seem like it. Let's see, what page is that on? It's at the top of page 409, and it seems very strange. It says, for any real number greater than 0 and not equal to 1, b of x equals b of f, or b of y, so sorry, b to the x power equals b to the y power if x equals y. And it doesn't immediately hit you what the implications of that are, so why don't we practice one? They give us a practice there in example 5. They say 6 to the x power equals 216. Well, we're trying to get these two things, or we're trying to kind of solve using the exponents. Right now, though, these are not in similar forms, so it's not really going to help us. It's not in this kind of form. See how we have the same base and we have different exponents? We have a 6 to some power, and then this is not in that form. So can we express 216 with the base of 6? And if you practice a little bit, you'll see that it's 6 times 6 times 6. And so we're going to rewrite that as 6 cubed. Does that make sense? So now that we've rewritten it with the same base, now this thing helps us. 6 to the x power equals 6 to the third power if x equals y. So in other words, x equals 3. Does that make sense? So get the same base, and once you have that, then the exponents are equal to each other. Let me show you a little more complicated one, but it's going to be the same kind of form. This is also in example 5. It's letter B. It says 25 to the x minus 1 equals 5. What power would that be? Be the first power, right? So we're not quite to here yet. We don't have the same base. We have 5 to some power and we have 25 to some power. So we need to rewrite this as 5 to some power. So you know you can rewrite 25 as 5 squared, and then that whole thing is to the x minus 1 power. And that equals 5 to the first power. Remember what we can do now is if the bases are the same, then it means these powers, these exponents are the same. So I'm going to just get rid of the bases and rewrite it as 2 x minus 1 equals 1. And then I'm able to do the distributive property. 2x minus 2 equals 1. And now I'm just allowed to solve for x. Bring 2 over to this side. 2x equals 3. Divide by 2. So x equals 3 halves. Okay? All right. So that's about all for lesson 3. And hopefully that makes sense. If not, we can talk about it tomorrow.